In this video, we're going to review some of the rules for naming compounds. If you recall, I gave you this chart. This flowchart is, I think, a huge help to going through on how we come up with the name of the compound or the molecule. The first thing we need to do is determine if it's covalent or ionic. And in order to do this, what you have to do is you have to look at the actual components that are in there. So if you have, it may be just easiest if we go ahead and let's do an example. So for the first one, let's look at cesium, CSBr. And the first thing we need to do, if this is problem one, we need to come down here and decide if this is an ionic or molecular compound. So the ionic compound, remember, is a metal plus a nonmetal. And the molecular is two nonmetals. So two or more nonmetals. All right, so CSBr on our periodic table, we can reference the periodic table. Cesium is down here, alkali metal, and bromine is over here. It's a nonmetal, so we know here that, of course, this is ionic. So with ionic, we make sure we have the cation. The cation, again, is going to have the positive charge. It's lost electrons. The anion is going to have the negative charge. So we have a cation. This is our metal. It becomes cation. And our anion over here. Now let's take a look at this. Now we have to next determine if it's binary, which it means it has two, or if it has a polyatomic ion that is a part of this. And both of these, this cesium, that's a single type of atom. Bromine, single type of ion. These are single ions, each one. And in this case, we're going to have a binary. So this is simply going to be cesium. And then with the bromine, we have to add the ID, E to the end. So it's cesium bromide. Let's take a look at another example here, the Li3N. So we first of all look up what we have here. Li is lithium, N is nitrogen. Lithium is all the way over here on the left. It's a metal. Nitrogen is a nonmetal. So again, we know we have another ionic compound. And then the next thing we need to look at is whether it's binary or polyatomic. In this case, it's binary. There's just two different types of ions here. And this has Li3. But in an ionic compound, this is ignored. You just give the name of the cation. So this is lithium. And here we have to add ID, IDE, so it's nitride is the name of it. Here's another example, BaSO4. So in this case, we need to find out what we're dealing with here. Ba, that element, we hunt around the periodic table. We find that element down here in our alkaline earth metals. So this is a metal. SO4, ooh, that's not a single element. That's multiple elements. So we're not dealing with a binary, right? We have a metal, so we know that it's going to be ionic because this metal is here. SO4 is one of our polyatomic ions. So what we need to go ahead and do is we need to take a look underneath our periodic table and see some of these common names here for the polyatomic ions. And we find SO4 right down here. Right, this is sulfate. So what we have here is barium sulfate. All right, let's take a look at another example. The next chemical formula we're going to look at is Fe2O3. Now what's interesting, this is iron and this is oxygen. Iron is a metal, but iron is a transition metal. And transition metals, many of them have multiple ionization states. So we don't, and if we're going to look at what the name is, we have to figure out which ionization state is being used in this compound. So let's go ahead and take a look. The key to doing this is, first of all, starting with oxygen. We know that oxygen has 6 valence electrons. It has an atomic number of 8, and 2 of those are in the first orbital. So if we take a look at oxygen and do a dot diagram, 1, 2, 3, 4, 5, 6. So each oxygen needs to gain 2 electrons, right? And this is a metal here. Metals are going to donate the electron. Each oxygen needs to gain 2. And there are 3 oxygen. So if you take 3 oxygen, each one needs 2 electrons. Right? 3 oxygen times 2 electrons each. And you know that there's 6 electrons that the oxygen needs to gain. The iron, there are 2 iron ions here as part of this compound. And so what that means is that these 2 iron ions have satisfied these 6 electrons. So divide this by 2, and you know that each iron has given up 3 electrons. And we would write that out in Roman numerals. So this is called iron 3 oxide. Now let's go ahead and take a look at some rules for naming molecular or covalent compounds. The first thing we need to look at is that all of a sudden we're adding in these prefixes. These mono, di, tri, tetra, penta, etc. These only come into play with covalent compounds, right? These molecules. All right, so the first thing we can do is we can look at an example like this, CO2. Most people know what that is. When you only have one atom at the front, so this is just one carbon atom in our first position, we skip this prefix. We don't put mono in front of the first element here. So we just call it carbon dioxide. All right, there's 2 here, dioxide. All right, another example. So we can go ahead and take a look at a classic one that doesn't often get this name, but H2O is, here we've got 2 hydrogen, so it's dihydrogen oxide. And you notice that, again, we're adding the IDE ending. Here's another example. We have SeCl2. Well, I know Cl is chlorine, and there's 2 of them, so it's going to get the IDE suffix, so it's dichloride. But Se, that's an element I'm not as familiar with. So we'll go ahead and take a look at our periodic table. And we will have to bring this to the front. And in our periodic table, we'll find Se over here. And if we zoom in enough, we will find that this is selenium. And here we go. You can start to read it. S-E-L-E-N-I-U-M, selenium. All right, now I'll get back out to zoom out. All right, and that is a nonmetal. Notice, remember from its location on the periodic table, it's right here. It's a nonmetal. There's two of them. So it's going to be diselenium dichloride. Two of them. Diselenium dichloride. But there's a few examples. I'll make another video with a few more examples for you.